Our planet is a vast repository of natural wonders, each with its own story and value. Beneath our feet, locked away in the ancient rock, lie crystals of incredible beauty and complexity. These are the Earth's minerals. Most are common, forming the very ground we walk on, but some are extraordinarily scarce. They are the result of unique geological events, a perfect and unrepeatable combination of temperature-pressure chemistry. Discovering them is like finding a secret note left behind by the planet itself. These rare minerals tell a story, a deep geological history, of how our world was formed, and how it continues to change. They are more than just stones, time capsules from a primordial age, holding clues to the very processes that shape our world. The pursuit of these rare minerals is not merely a treasure hunt, it is a scientific endeavor of the highest order. Each new discovery can rewrite our understanding of geology and chemistry. These substances often possess properties unseen in more common materials. Their unique atomic structures can bend light in strange ways, exhibit unparalleled hardness, display colors that defy description. For centuries, humanity has been captivated by such gems, not just for their beauty, but for what they represent. In our modern world, the importance of rare minerals has taken on a new dimension. Think of components in our mobile phones or advanced materials used in space exploration. While the minerals on our list are often too scarce for industrial use, studying their structures inspires scientists to create new synthetic materials. The quest to find them drives us to the most remote corners of the globe, highest mountains, deepest caves. The story of these minerals is a story of discovery, of science, and of our enduring fascination with the beautiful and the rare. It is a journey into the very heart of the Earth, a world of crystalline forms and breathtaking rarity that continues to surprise and inspire us with every new find. To truly understand the value and application of these minerals, scientists and collectors classify them by both cost, high, medium or low, and by their primary usage, industrial, scientific, ornamental or collectible. This classification helps us appreciate not just their rarity or beauty, but also their role in technology, research and art. Throughout this video, we'll highlight each mineral's cost and usage, so you can see how these hidden treasures shape our world in different ways. Among the rarest of all minerals is painite, a gemstone so scarce it was once considered the rarest on Earth. Today it is prized for its deep reddish-brown color and extreme rarity. Painite was first identified in the 1950s by British gemologist Arthur Charles Davy Payne, who acquired two dark red crystals from Burma, now Myanmar. At the time, only these two specimens were known to exist. Painite's value is determined by its rarity, clarity and color. High-quality stones can fetch over $50,000 per carat at auction. Because of its scarcity, painite is mainly a collector's gem, rarely set in jewelry, and almost never used industrially. The mineral's unique chemical composition, containing calcium, zirconium, boron, and aluminum, makes it a scientific curiosity. However, its extreme rarity and high cost prevent any practical industrial application. For decades, painite was listed in the Guinness Book of World Records as the world's rarest gemstone. Even today, only a few hundred crystals have ever been found. Close behind painite in rarity is taphite, another mineral with a fascinating story and a high market value. Taphite was discovered by chance in 1945 by Irish gemologist Count Edward Charles Richard Taffa, who noticed a pale mauve stone behaving differently from spinel. It was later confirmed as a new mineral. Taphite's value is based on its color, clarity, and size. Fine specimens can sell for tens of thousands of dollars per carat. Like painite, taphite is too rare and valuable for industrial use, and is sought after by collectors and jewelers. Taphite is found in only a handful of locations worldwide, including Sri Lanka, Myanmar, and Tanzania. Its colors range from colorless to lavender, mauve, and reddish violet. Both painite and taphite are classified as collectors' minerals, valued for their beauty, rarity, and the scientific insight they provide. Their high cost and scarcity mean they are admired in museums, private collections, and occasionally in high-end jewelry, but never in industry. Sharing a close chemical relationship with taphite is another exceptionally rare mineral, musgravite. It was first discovered in 1967 in the Musgrave Ranges of South Australia. For many years the original finds were not of gem quality and the mineral remained a curiosity for scientists and specialized collectors. Later in Sri Lanka, Madagascar, Greenland, a few rare transparent gem-quality crystals were unearthed. Musgravite is a beryllium magnesium aluminium oxide. It is so similar to tophet that it can only be reliably distinguished by X-ray analysis, Raman spectroscopy. Its colors are subdued, grayish-green, grayish-violet, deep, almost black-green. The extreme rarity of gem-quality musgravite cannot be overstated. By the early 2000s, only a handful of faceted stones were known. Another member of this exclusive club is Grandidierite, discovered in 1902 in southern Madagascar by Alfred Lacroix, named for Alfred Grandidier, the French explorer. Grandidierite is famed for its bluish-green color. It shows strong pleochroism, different colors from different angles. It can appear blue, green, clear. For nearly a century, gem-quality Grandidierite was almost mythical. Transparent crystals large enough to cut were virtually non-existent. The original Madagascar site yielded few facet-grade specimens. In 2014, a new deposit near Tranamaro changed that. The find brought a small but significant number of high-quality transparent crystals to market. Even so, Grandidierite remains among the planet's rarest minerals, a testament to Madagascar's unique geology. Our journey into the world of rare minerals now takes us to Jeremejevite. Discovered in 1883 by the Russian mineralogist Pavel Vladimirovich Eremeyev on Mount Sokhtui in Siberia. This mineral is a true geological marvel. The initial crystals were small, sky blue in color, and in a perfect hexagonal form, like tiny frozen columns of ice. For a long time, the Siberian locality was the only known source. Specimens appealed mainly to mineralogists. In the 1990s, a new source was found in Namibia. The deposit yielded larger, often flawless crystals. Some were deeply saturated blue, others completely colorless, and some pale yellow. It is an aluminium borate mineral. Its hardness makes it suitable as a gemstone. Its range of colors and exceptional clarity make it incredibly rare and desirable. A well-formed deep blue Jeremejevite is a masterpiece, a perfect expression of crystalline geometry. Perhaps one of the most gently beautiful and obscure minerals is poudretite. It began in the 1960s at the Poudret Quarry in Mont-Saint-Hilaire, Quebec. The first poudretite crystals were tiny, pale pink, and barely recognizable. It was officially recognized in 1987 and named for the Poudret family. In the early 2000s, a discovery in Mogok, Myanmar changed that. Miners found larger gem-quality poudretite. These stones showed a beautiful pink color, excellent clarity, and brilliance that rivaled kunzite. One faceted stone over 9 carats ranks among the finest. The mineral is a complex silicate containing potassium, sodium, and boron. The final mineral on our list is serendibite, a name that evokes the old Arabic name for Sri Lanka, Serendib, which itself is the origin of the word serendipity. It was first discovered in Sri Lanka in 1902 by a Sri Lankan mineralogist Ananda Kumaraswamy. The original specimens were a dark, almost black, greenish-blue. Serendibite is an extremely complex silicate mineral containing calcium, magnesium, aluminium, silicon, boron, oxygen. Its intricate chemical formula contributes to its rarity, as it requires a very specific environment to crystallize. These Sri Lankan stones are typically very dark, so dark in fact, that their true color is often only visible when a strong light is shown through them. The story of serendibite took a dramatic turn in the late 1990s. A new discovery was made, once again in the fabled Mogok region of Myanmar. This new find produced serendibite of a completely different character. Instead of the dark, near-black stones of Sri Lanka, the Burmese material was a brilliant cyan, greenish-blue. These stones were much more transparent and displayed a wonderful pleochroism, shifting between shades of sapphire blue, yellowish-green, violet blue. The Burmese material in particular is considered one of the most beautiful and rare color phenomena in the gem world. It is a true jewel of serendipity, a beautiful accident of nature's complex chemistry. The minerals we have explored, painite, taphite, musgravite, grandidierite, jeremejevite, poudretite, serendibite represent more than just geological oddities. They are the crown jewels of our planet's mineral kingdom. These stories remind us the Earth is a place of constant creation and hidden beauty. Each crystal is a survivor preserved for millions of years and waiting to be discovered. The discovery of each has been a milestone in geology and mineralogy. As we explore our planet's highest peaks, deepest oceans, we will find new minerals, each with its own story. These unseen wonders are part of our planet's heritage, enriches our science, inspires our art, deepens our connection, a legacy of geological time that ties us to this extraordinary world. Thank you for watching. Please don't forget to subscribe, like, comment, and share this video to help support